Good morning. If anybody's out there, feel free to ask any questions. Uh, I'll just kind of give a general idea of what the exam is going to be on, which is obviously everything after muscles. So your midterm was all about muscle function. This is every lecture after muscle function, movement strategies, and uh, the kind of history of biomechanics. You go into movement strategies for strength, power, max speed of distal segments, and everything that we do is some combination of those. Um, so if something's real heavy to you and you have to throw it as far as possible, you're not going to throw it like a light object. You're going to have to adapt the strategy um, accordingly. That's why new people, novice people, tend to start off with simultaneous strategies because it's more about being accurate when you first start something. Then you can learn to be faster at it. People don't just put on roller skates, nice sequence motion, right? You typically roll on both legs and have someone push him. So we got that stuff, and we go into chains, and which is a movement strategy where distal segment's free to move or distal segment is fixed, and that could be fixed to prevent simultaneous motion, multiple joints moving at the same time, or sequenced motion where you have one joint that can move independent of other joints. There's that. Then we get into Newton and his laws and kinetics and kinematics and what are the definitions of those principles, kinematic principles, position, velocity, accelerations. Kinetics is forces, muscle forces, weight, gravity, ground reaction forces. We go into Cartesian plane and angles. So applying forces at different angles, you need to be able to see that quadrant one. So there's positive x. Then the pathway to positive x to positive y is the first quadrant. That's the pathway to go from here to there. And any force that is being applied in quadrant one has a combination of some of this and some of that. All of this, summa, all of that. So anything in quadrant one has a combination of x and y. The pathway to positive y and negative x lies through quadrant two. Anything in quadrant two is some of this and some of that. All positive y, summa, all negative x. Okay, same thing for quadrant three. Quadrant three is the pathway from negative x to negative y, and quadrant four is the pathway from negative y back to positive x. So I'm not going to ask you to solve for x or y, but you got to understand that if there's a force that's being applied here, all of that magnitude is positive x. And if it's at an angle in quadrant one where some of it is here and a little bit of it is, you have to be able to see that since this is applied less than 45 degrees, a majority of that force is going to be positive x force, and just a little bit is going to be positive y. If I get to 45, x and y are going to be the same. Why? Because it's halfway. The pathway from here to there is 90 degrees, and halfway is 45. It's that simple. So if you're halfway, you're going to have just as much here as you are there. If you're traveling northeast at a 45-degree angle, you're going just as fast north as you are east. Same thing. If you go past 45, now more of that force is going to be y and less of it is going to be x. So I need you to be able to see that. I need you to be able to see direction. If I'm in quadrant one, I have a positive x and a positive y. If I'm in quadrant two, I have a positive y and a negative x. Quadrant three, negative y, negative x. Quadrant four, negative y, positive x. I need you to be able to see that. Okay. Not solve for it, but you got to be able to see it. Cool. Some other things we talked about in the lectures: moments and torques and levers and being able to see. I'm not going to ask you to calculate. Now, if it's a common sense calculation, good Lord, you guys need to be able to see that. Like if I tell you that a force of 1,000 pounds is applied at a distance perpendicular of 0, like in other words, that force is applied with no moment arm, you need to inherently see, oh, well, then the torque is 0. If I'm trying to push on the axis of rotation, I'm not trying to spin anything. Okay. If someone takes my arm and pulls straight down, they're not trying to ab or adduct me. They're just trying to dislocate me. Okay, that kind of stuff. So all I could suggest is review the lectures, and I'm going to actually post this video for today, hoping that you watch it today, and know that you have all day today and all day tomorrow to ask me questions, hit me up, clarify. So that is your lecture, or that's your assignment, is to study. Watch those lectures and only hit me up if there's clarifications, okay? All right, guys, y'all be well.